Yes, that was all I really had to say. It was my pleasure to introduce you to Daniel Mayer, who's the CEO of one of our partners, one of our MarkLogic partners, Expert System, acquired Temis a while back. And he'll be talking to you on what's your AI strategy. And if there is time for questions at the end, I'll be running around with the microphone, so please don't sort of shout them out because we are recording these sessions to be posted on MarkLogic later, and we want everyone to benefit from the smart questions that you ask. So, thanks.
So hi everyone, I'm Daniel Mayer. I run the US operations for Expert System. And we've been a MarkLogic partner for something like 10 years. This is my 8th MarkLogic event, I believe, and I'm going to speak to you a bit about your AI strategy, a specific part of your AI strategy that deals with natural language processing, which, as you probably know, is a key technology for enriching your content or extracting information from your content, to improve your metadata, to improve triples, and so on, and build more powerful applications on top of MarkLogic. As I was working on my slides of these past few weeks, I realized that actually I was preparing 2 talks at the same time. As you'll notice in the slides, and it's been a bit difficult to work this out, but there's a business track and there's a technical track in this slide deck. And it's going to be difficult, but I'm going to try to cover both aspects in parallel as I go through this. So before I start, I'd really like to know how many of you consider yourselves to be more on the business side. Could you raise your hands? Okay, thank you. And more on the technical side? Okay, so overwhelmingly technical. That's unfortunate because my slides are overwhelmingly business-oriented. So I'm going to try to resolve that live. And can we get also a little poll with respect to the sector in which you work? So anybody out there in publishing and media? Okay. Anybody out there in financial services? Okay. How about insurance? Anyone in insurance? Okay. Anybody from IRS? IRS, anyone? Okay. That was a joke. All right. So we're going to talk about business and technical. I'm going to go through a little intro regarding our company, what we do, and then I'll quickly go into case studies, 3 case studies, which I think is really the core thing, and then hopefully we'll still have time at the end for questions. We are what we believe to be the largest pure play vendor of this type of technology. We're in 7 countries, about 250 employees worldwide. Our platform is called Cogito. You may have met us in under other disguises because we were Temis in a previous life. Temis and Expert System merged last year, so now we are Expert System. We are present in a variety of verticals, as you can see. Media and publishing has been a very strong vertical, for us, for MarkLogic and other companies in this space, obviously, but we do a lot in public sector as well. Financial services, pharmaceuticals, and other industries. So the use cases I'll be discussing today are mainly coming from insurance, media, and banking, but they're only examples. Every application is different. So please don't keep in mind that we do those 3 specific things because it's very diverse. So the problem that our software addresses is language ambiguity. Here I have 2 sentences up there that use common words. So the word apple, the word stock appear in both of these sentences. And all of us in the room are able to recognize that obviously they don't designate the same concepts. For a machine, this is very mysterious. Okay, and this is what we call disambiguation. So disambiguating between Apple the company and Apple the fruit is a tough problem for a machine. And the way a machine resolves that is typically by leveraging context. So the context of those words helps disambiguate their meaning, and that's what our software does. So our software resolves textual ambiguity. This is one example, but I'm sure in your business you've run into all sorts of these little corner cases. And essentially, this provides all sorts of capabilities within an application. So let's look at some of these applications. Document classification can be addressed with this type of technology for routing or triage applications, navigating within topics, answering questions. For the simple cases can be addressed with this, this approach. Fingerprinting documents to understand, what is there, what type of appear in a document, what other documents refer to the same concepts. This could be for recommendation or for deduplication tasks. Extracting concepts, for example, relevant to a domain or an enterprise taxonomy or ontology. For example, for navigation. Extracting what we call entities, so in other words, objects of interest, such as the names of people, of companies, of locations, as well as many other objects that appear in, as business objects in your applications. Some of these things can be resolved with what we call thesauri or lists of words, but think of people names. How do you address people names with a list of people names? That's going to be tough, especially if you want to identify people who are not on the list. You're not going to be able to resolve that with a list. So that's where you need guessing, and our technology provides different techniques to guess these things. And also, of course, extracting relationships or claims that a relationship exists between objects. This is where we feed MarkLogic, for example, with triples. If you want to identify the role of an entity in a relationship, if you want to establish cause and effect, and so on, that's where this is particularly useful. So as you can see, it goes from, pretty mundane tasks all the way to really the most high-value information extraction activities. So if you look at MarkLogic, this is a slide I built thinking of MarkLogic 9. So the way our platform integrates with MarkLogic is through the content processing framework. Documents get sent to our platform, and we feed back triples and metadata inside MarkLogic. Once those have been, once the content has been enriched, you can query MarkLogic. I don't know if you're using MarkLogic 9 yet, of course, but if you're querying for search, for SQL, for Sparkle, that's what you're going to be able to query. And going forward, the Optic API is going to be, one of the options there to query MarkLogic and feed your application. There are a few examples up there with information coming from this repository. Let's look at an example, really to situate ourselves. I'm not going to go very far, but I wanted to show you this because I think to speak to the technical crowd here, this is an example, raw document that we have, and this is what the enriched document looks like. So there's a variety of ways of enriching MarkLogic. This is the inline enrichment option. You can enrich with triples, standalone triples. We can do that as well. The exact syntax can be modified to fit your needs, but this is just an example, to illustrate what we do. So we go essentially from the raw document to the enriched version. Here you can see a couple of things. You can see, in fact, you can see a relationship, which is an acquisition relationship where a company called TEPCO, has acquired fuel oil. You can also see mention of entities. TEPCO is an entity, it's a company. Fuel oil is an instance of the concept of petroleum that occurs in the document. So this is a visual representation of what we do. Our claim to fame is that our platform, contains a few unique features, but I think this is an outstanding one, which is our linguistic knowledge graph. Linguistic knowledge graph, this is a screenshot of part of it, if you will, an artist's representation, is that the platform contains a dense knowledge graph of concepts that occur in the language. So here you can see the word pen, and that word actually has many meanings associated to it. So distinguishing between the different meanings of that word, we use this graph to interpret context and narrow down to the precise meaning of the word in context. Okay, so this is an operation that, thanks to this linguistic knowledge graph, can be really streamlined, and the platform takes care of, let's say, the most common ambiguity cases, so that in the context of your project, you don't have to deal with most of these cases. The only cases that you need to deal with are those that are specific to your domain. So essentially, it streamlines, the effort required to bring this type of technology up to speed with your content. Recently, a colleague of mine told me that a competitor, a well-known three-letter competitor, said that their platform was like a baby and that you could teach the baby any new domain. So our platform essentially is like a grad student, okay? And you can teach the grad student about your domain. You don't have to start when that individual was a baby. So you don't have to teach them the language from scratch. You can start from a very high level of understanding. So essentially, it's a very low total cost of ownership and operation platform. Let me speak a bit about the business side. So we've been in this business for something like 25 years, and we've dealt with many different use cases, and we've boiled it down to 2, believe it or not. So it's a bit exaggerated, but really I think there are 2 categories out there of use cases that we face most commonly. The first one, I'm going to try to stay on the first one, deals with productivity gains. So any piece of software that brings automation, carries the potential for productivity. Productivity in the sense of speed, in the sense of scalability, processing more content, reprocessing content if you need to over the period of a weekend. So all these are different faces of productivity. So if you have a labor-intensive process somewhere that involves people and paperwork, that's the symptom, you can address that with any technique that helps you to bring productivity gains into the workflow. So typically, it's going to be process automation contexts. So for example, in insurance, I'll talk a bit about claims and underwriting as areas where automation can currently be brought to the fore. In compliance, there's enormous amounts of people and paperwork. So that's an area also where we do automation work. Customer interaction with chatbots and so on. That's an area that's seen a lot of development recently. I want to point out that it could be full automation or it could be hybrid automation. We do both. Okay, years ago, if we had spoken 10 years ago, or anyone in my position would have talked to you about full automation because that was the thought of the day 10 years ago. We're going to automate these things. Today, we've come back from that concept. It depends really on the application, but in many applications, we can provide hybrid automation solutions. So the software resolves 90% of the equation, and human operators are there for quality checking. It happens very often. Information management tasks fall into this category. So if you're improving the metadata within your repository for search, for example, for content integration, for content assembly, if you're in media, these operations are heavily reliant on our ability to automate the indexing task. So that's the first category. A second category of use case is really related to insights. Insights really dealing with many different things, but insights leading to better decisions. I think one of the 2 early areas where insights were a big thing were intelligence in the homeland security sense, and scientific R&D. In both those fields, people used this technology, this was 15, 20 years ago, to get insights, to piece together elements of information. Who is this person connected to? Are they part of a larger group of criminals that maybe we know about? Is there a way of connecting them to other people? Or let me look at the side effects of a drug. Let me process 100,000 scientific abstracts, find out what are the effects of this drug? Are some of these adverse effects? Are they, in some cases, therapeutic effects? Can I repurpose that drug, for a new therapeutic area? Those kinds of thinking processes can be fed with insights that are extracted from, a lot of unstructured content. Other use cases in industry involve, customer feedback analytics, competitive intelligence, finding early signals of what your competitors are doing, finding clues in your maintenance reports as to how products can be improved based on, the pattern that you can find in terms of failures, and so on and so forth. Smart exploration in oil and gas, that's been a theme as well. So really 2 sides of the coin, productivity gains on one side, insights on the other. And I'll try to refer to this frame, in the 3 case studies. So let's look at insurance first. We believe that insurance is set to go through a strong turning point, starting maybe 18 months ago and accelerating going forward. the industry has realized that some of its key processes, such as claims, such as underwriting, can benefit from a degree of automation. Not to say that everything is going to be automated. I don't think it will be. But we believe that depending on the type of claim, depending on the type of insurance, we will see going forward more and more automation in these processes. Those processes, by the way, involve people and paperwork. Very convenient, mechanism to remember that. Another aspect of insurance is leakage and loss in the larger sense. So, in other words, the amount of money that insurance companies pay out, to the insured. Here as well, risk insights can feed that process, for example, to improve the underwriting models, for example, to decide on mitigation actions in certain cases, detect fraud, and so on and so forth. So the fundamentals of the insurance business are essentially well aligned with the capabilities of this technology. Here's some information regarding a project that we have worked on for one of the largest property and casualty insurers. I can't tell you the name of this company, but I can tell you a bit about what we've done with them. Their pain point was a slow and costly claims management process. So the claims management process, for those of you who are not aware of it, is the process that starts when somebody calls and says, I've had a car accident, my house burned down, or something like that. And that starts a process of reviewing, what happened, and first of all, establishing if, the event is covered in the policy, and then if it is, to decide, what reimbursements will take place for the insured. So that's the claims process, and the claims process involves teams of people who go through documents. So here I'm talking about some claims packages that are 100 pages long, and they need to decide based on the facts of the case, is this within the policy? What are we going to reimburse? And so on and so forth. For this case, these were claims that were, let's say, low to medium severity. So in other words, not the most extreme cases, but not the smaller severity either. Typically, a claims handler might spend throughout the life of the claim 3 to 5 days, within that decision process that I was referring to. So the point was, how can we accelerate that? The goal was not to automate fully. The goal was only to provide a degree of automation. And what we did was streamline the review time from days to hours on the claim. So that's not 100% of the claim processing time, but it's a big chunk of it. And we brought a tremendous amount of productivity there. Let me show you a bit of how that works. So, there's an element of OCR for incoming documents. Then they are classified. We need to decide, is this a medical report? Is this a police report? Is this a claim demand letter? This type of thing. And then we need to extract information. You're going to see examples of this in a second from those claims to then present them to the claims handler in a streamlined way so that they can take all those decisions more quickly. Once they've taken decisions, obviously, they record the decisions and they close the case. So here is what we call the claims management interface that we built for this project. Here's what it looks like. It's not a screenshot, as you can see. It's not attempting to be a screenshot because there's things that I can't show you. But I can show you these elements. So based on what we extract, we rebuild the claim timeline. So they have a term in insurance called FNOL, which is first notice of loss. So from the first notice of loss to the end of the case, we rebuild the history of the case. This is really important because they need to understand, what is the sequence of events that led to the status in the claim. So that's a key piece of the interface. Then we provide extracted concepts that come out of the different documents in the claim. Here you have a few examples. Name of claimant, date of birth, amount of that's requested by the claimant, nature of the accident, items of description in the accident, and many other concepts. So, for example, if you click on demand amount, you're gonna find a highlight in the interface immediately to that area in the claims package where the demand amount is referred to, and so on and so forth for every element. Here are some other elements that we recover. So, what body parts were involved in an accident in this case, ICD codes for diagnosis information, who are the providers that were involved in delivering the healthcare services that are referred to. In some cases, there are drug names. And very interesting in the bottom right, there are some flags. So these are flags that are very indicative that they're indicative, let's say, of the severity of the claim and particular action that should be taken, on a given claim. So every insurance company has their own strategy for handling these things, but, one example could be that if an uninsured motorist is mentioned, in the claim, that's something that they want to know very early, because that could be, a pointer to perhaps a higher degree of severity. Was the insured, forced to take some time off work? This type of criteria can be really important in deciding what you do with a particular claim. So through this interface, that's how we help them save time. Instead of having to collate the information by hand, it's done automatically for them. All they have to do is review the information, navigate very quickly in the claim, and essentially that's how we streamline, from days to hours, literally this process. Here's an additional feature that we were able to build into a claims process, detecting inconsistencies in the accident description. So in the medical report, we find a statement saying that the client was driving through, this road. In another document, we find a slightly different statement that says that the car was stationary on the road. So which one is it? Obviously, establishing responsibility in an accident, this type of clue is really essential to that. So from the standpoint of the insurance company, being able to make sure that on one hand, they get the story right, and on the other, they don't pay for something if the insured isn't responsible. Those are really important things. In some cases, inconsistencies like this can point to fraud attempts as well. So that's where this is going. Let me show you part of the back end of this project. I'd like to show you how we extract this type of information. So let's assume that there's a sentence like this in the document. Your insured swung his car to the left. Part of the process here is deciding what type of accident took place. Okay? Because if you know what type of accident took place, and this is a partial, by the way, screenshot on the right of the list of categories of accidents. So insured changed lanes, insured emerged from a road, insured reversed into the third party. This was a multiple collision, or third party changed lanes. So this sentence refers to this last case, case number 5, third party changing lane. And the list goes on. And the conditions for insuring these types of accidents are all different. So they're a key part of the decision process. So this is an example here, and it's a partial example of an example of rule that we build to recognize which case we're dealing with. So this is not the end-all be-all, right? So it's not 5 lines of code that help determine which category we're in. There's hundreds, if not thousands, of lines of codes. But this is an example. So here we look at sentences, and we try to find sentences where it's written that a third party swung the car. So we try to find sentences that basically are according to this model up there. Okay, we use as I mentioned earlier. So we have a thesaurus that determines ways of naming a third party. Okay, so another driver. There are variants to name that. We locate that in the text, and we find sentences where the verb swing has been used. Then concept that pertain to vehicles. And then identifying that the car has swung to the left or to the right. So this is just one pattern that we build to find this type of sentence. There are hundreds and thousands of patterns to find other cases as well as other ways of expressing the same thing. This is one approach. This is a rule-based approach. It's called morphosyntactic reasoning, reasoning on the shape of sentences. It's just one way of using our platform to extract information. And this is, going back to what I was saying earlier, this is part of the technical side of the story. I'll get back to that at the end of my talk. If you want to enrich your data with these types of concepts, you will need to come up with an enrichment strategy. So there is a business strategy to dealing with your application. What is the use case? What's the return on investment? Am I going after productivity gains? Am I going after insights? Which category of use case am I going to find myself in? But there's also a technical side to the story, which is, what is your technical strategy for implementing this? And obviously you have your repository, you have MarkLogic, you're going to build search or other analytics on top of that, but also there's the enrichment in the bottom, and that requires a strategy. And these are examples of strategies that you can deploy for those projects. Let me go through a second example, this time in publishing and media. So we've done a lot of work in publishing and media over the years. We found that productivity plays out in a big way in publishing and media. Publishers and content providers in the larger sense, have built automation into their processes, and they've been doing that for years. But also, they've been building products that are as differentiated and compelling as possible, essentially acting as a proxy, if you follow me, to deliver insights capabilities to their customers. So if you're a scientist and you're reading scientific journals, or if you're a lawyer and you're searching through case law, if you're a construction contractor, these are actual use cases, and you're looking for RFPs for construction projects that you want to bid on, but you only want to bid on those where you have a chance of winning. All those are forms of insight delivery. So, how can I repurpose my drug? Give me insights. How can I bid more effectively, my construction services? All of those are insights that these audiences are looking for, and publishers have been delivering insights, by proxy, essentially. So in publishing and media, we find a very good mapping to those two types of projects. Here I have some screenshots from a project that we did with Sage, one of the largest social sciences publishers out there. The product name is Sage Recommends. What's very practical with a lot of these media products is that they're online, so that it's very easy to access. By the way, you can access Sage Recommends. You can't access the final content, but you can access this interface, search, and use the Sage Recommend tool. So you could actually test it if you'd like. The way it works is that if you're reading an article, in this case about the Rosenthal Effect, I'll go into what that is. If you click on the right, there's that little Sage Recommends purple fold out, and you get recommendations for other documents that refer to the same topics. And you get recommendations for documents coming out of different Sage product lines. So there's Sage Methods up there, research methods, there's Sage Journals. I have other screenshots where there's Sage Data. So they have different products, and if you're subscribing to one product, through this feature of their website, you're going to get recommendations to other products. So obviously for you, the value will be getting insights from areas that you're not a subscriber to. For them, the value is, well, let me see if we can get you to become a subscriber to those areas that you're not a subscriber to. The way this is built, in fact, it uses a combination of two things. It uses our platform to extract the concepts that appear in the documents. And a very original and unique feature in this project is that it uses a social sciences thesaurus. Most recommendation engines out there rely on statistics purely. There was no thesaurus in social sciences, but they felt compelled to build one to improve the quality of the results that they were getting from the recommendation engine. So a nice example of how this plays out is the following. Rosenthal effect, for those of you who, like me, don't know what that is about, is in fact the self-realizing prophecy that a teacher's perception of a student has on the student's result. So teacher thinks that a particular student is gifted. Well, statistically, that student is going to get better results. Teacher thinks that the student isn't particularly gifted. Statistically, that will cause the student to have worse results in that class. So that's called the Rosenthal effect. But the Rosenthal effect is terminology that's used mainly in North America. Outside of North America, there's another term that's used. It's called the Pygmalion effect. So if you're sitting in India and you're looking for, I use India because India seems to be highlighted there. If you're sitting there and you're looking for Pygmalion effect, you're not going to find the documents that refer to the Pygmalion effect if they refer to the Pygmalion effect under the term Rosenthal effect. You're not going to find those. So there's a part of the insights that are available that you won't find just because the words used are different. Sage resolved this by creating this thesaurus that establishes, synonymical properties such as this one. Rosenthal effect and Pygmalion effect, those are alternate words for the same concept. That's the type of thing that our software is able to resolve. The result is, in the previous screenshot, that you may have noticed that, for example, the number 2 and 3 documents refer to Pygmalion instead of Rosenthal, and still they're recovered. So that's one of the benefits. We call that increased recall. So let me give you an impression of the back end of that project. So our platform includes some rule building technology I referred to earlier. It also includes thesaurus and ontology management features. This is a screenshot from part of our platform that deals with the particular part of the process that I was referring to earlier. So in this case, I apologize, the screenshot is really small. Rosenthal effect is one of the concepts occurring in the thesaurus. You can see instances of that, but you can also see, if you squint, that we list Pygmalion effect as an alternative for Rosenthal. Language ambiguity, can come from alternative terms for the same concept, but also can come from alternative meanings for the same string of characters. So here I'm using an example, which is the word race. In the context of social sciences, race most often refers to the ethnicity. So there, of course, there's many studies related to race in society. But race is also a word that can mean, a sporting event. Or in this case, they're referring to elections, okay, electoral races. There's no way of anticipating this. These are actual examples coming from Sage's corpus. So these are actual issues that come up in their corpus of documents. It's not an invention. So ruling out these false positives, as we call them, it can be done, by leveraging context. So if we indicate that election, is a typical item of context for race in the sense of electoral races, that helps us weed out, these false positives. So in this case, not only in improving recall, but improving precision of the results. The social scientist in this case won't have to read through documents that refer to electoral races because maybe that's not what they're interested in. They will focus, strictly speaking, on the other meaning of the word. And let me show you a last feature of this part of the platform, which is that when you're building a taxonomy, a thesaurus, an ontology to apply to your content, and one of those, we call them TTOs, thesaurus, taxonomy, ontology. You want to organize your content or your knowledge or your information according to that type of schema. So you need to have a place where you can define that schema, and this is the place in our platform. But how do you build that schema in the first place? So someone asked me this question earlier. Some lucky customers already have a schema. In some cases, there are standard schemas in different industries. The scientific industries are well endowed in this respect because they're pretty mature in the way they use terminology. But then you have industries where there are no schema. So for example, social sciences was an example. Just a few years ago, very few schemas available for social science. And honestly, there's a lot of industries still today. I'm thinking of financial services, insurance. Parts of those industries don't necessarily have a very deep or detailed schema available. So in that case, you need to build one. In the case that there is actually a standard schema, you may still want to customize it. So this type of thing is useful nonetheless. The way you can build that is, for example, by using this type of feature where this type of platform can identify concepts in documents for your review. So in other words, it's as though you're asking the platform to show you what interesting concepts the platform can find in your content. Then you can query that. And these are just examples of queries. So for example, the first one was, show me all the concepts that include the word effect. So something effect. This was built on the previous example, the Rosenthal effect. Show me all the other effects that I can find in my content. And the platform points them out. Show me examples of policy that occur in my content. Show me examples of treaty. So show me all the treaties. And they are there. And you can literally drag and drop these concepts into your taxonomy, thesaurus, or ontology, your TTO. So this is another way that the platform can help you drive efficiency in your back-end operations when you're building one of these or maintaining it. I'm going to go into my last example, which deals with finance. And remember, the frame I had earlier on was that the use cases fall into categories of productivity gains or insights. So here again, accelerating workflows. I'm thinking, for example, of compliance workflows, for example, related to AML or KYC, as well as other regulations. Anonymization is something that was mentioned earlier. It's not only, by the way, about removing people's names. It can be pretty intricate. You have to remove certain people's names, but not all the people. In a legal decision, you're not going to remove the names of the magistrates. You need to remove the names of the parties of the case. You're going to remove addresses, because if I know the address, I might be able to infer who's at stake in the case. But you're not going to remove the addresses of things that are unrelated to the parties. You're going to have to remove certain company names, because if the company name contains the name of an individual, that's an issue. But it's not going to be all company names, because if the company name is just a company name, it's okay to leave there. So it's not only about removing people's names. It's very intricate. There are other examples here. And as far as insights, my case study is going to be on customer feedback analytics. But there's all sorts of insights-driven processes in financial services as well that can be addressed with this technology. So here I'm really going to speak about cases where this is an actual customer project where we help them analyze customer surveys and generally speaking, customer feedback about their products and services. As you know, retail banking is a fairly regulated industry, very difficult to differentiate yourself. This particular bank decided to make customer satisfaction and the quality of customer relationships, the #1 factor for differentiation. The way they did this was understand what customers were happy with or unhappy with, and based on that, seek to improve their products, their services, and the way they address the customers. So really here, it's about triples. I gave you examples of, rule-based information extraction, TTO-based information extraction. Here, it's really about extracting triples. And here's an example triple. In this project, we were interested in opinion triples. So in other words, statements or claims made in documents about part of the product line or part of the service. So in this case, you can see a feature of the service was the opening hours of the branch office and picking up comments where the customer has expressed an opinion, positive or negative, and grading it and linking it to the target. So it's a pretty sensitive project in the sense that the particular taxonomy that this bank is using is their own. And parts of that are easy to anticipate, and most of what is displayed here is pretty easy to anticipate. And these are products and aspects of the service. And parts of the way they look at their business is a bit more proprietary and is not represented here. This is a partial representation of their product and services taxonomy. So there's things here that you will anticipate, like comments about personnel, about the branch, comments about the teller, comments about an ATM, and all these different types of aspects of their service. These are the most obvious. And what they've sought to do is reconnect people's opinions to these features of their products and services. The way it looks, in the application itself is like this. These are actual analytics that they drive based on customer comments. So you can see it's by theme, whatever the theme they want to look at, how opinions are evolving over time. It's by area, is one county more happy than another? Is there anything to infer from that? What can we do locally to improve customer satisfaction? looking at the spread of comments across time. Are there certain topics that are, spikes at a particular point in time that we should focus on? As well as interest level by customer type for different product ranges. So these are some of the analytics. I'm sure you can, you can infer the type of decisions that they take based on this, but the fundamentals are really that they run internal customer satisfaction reports, 10 such reports per month annually, as well as on specific topics. Churn is one thing, but they look at particular products like consumer credit. They look at particular customer bases like young adults. Aspects of their services, is our pricing good, or is it generating issues? And essentially, they can build these analytics in a matter of days instead of weeks in the past. So here you see we can mix the aspect of productivity and the aspect of insight. Okay, so I'm gonna conclude, and hopefully I'm within our time. So what I was trying to highlight in this slide deck is really that there's two tracks. There's the business track and there's the technical track, and I think you need to take care of both. On the business track, one thing that's really useful is to frame the use case that you're going after. So I suggested a frame earlier. I hope it fits. If it doesn't, I'd be interested to know why, because it could be a new type of use case that we haven't dealt with. What we see oftentimes is that low-hanging fruit projects tend to be a nice starting point, and typically you need to generate a certain form of momentum inside your company to drive these types of projects. So it's good to start with something which has a quick payoff, and then go on to more strategic long-term initiatives. We've seen that approach seems to work pretty well. And another aspect of the business question is really that there's a certain amount of change management that needs to take place in most companies that approach these topics. It involves re-engineering some of the processes, but also bringing into the company or bringing into the project, in certain cases, new skill sets. I'm highlighting some of those skill sets below. On the technical side, I think fundamentally you do need an enrichment strategy. So you need to decide what you're going after in those documents. What kind of insights, what type of tasks are you trying to automate, if that's the case. And to do that, you need to build a strategy for extracting that type of information. Obviously, we can help you, but there's a variety of techniques. I illustrated rule-based, thesaurus, taxonomy, ontology-based extraction, triple extraction. These are all forms of technology. The people who can help you formulate a strategy will typically be among these three groups of people: knowledge engineers, so people who are familiar with structuring knowledge in a thesaurus, in a taxonomy, in an ontology. That's a whole business. That's a whole science in and of itself. Then you may be surprised, but your subject matter experts hold a big part of the equation, because they know what is especially important in these cases. So they know what to look for, and they're an essential part of the equation. The knowledge engineers will want to work with your SMEs to code all of this, because whoever you work with for this type of project, they're not going to be your expert, probably. They're not going to be an expert in your domain. You're going to be the expert in the domain. You just need to pull in the right people from your teams into the projects. And lastly, computational linguists. So these are people who know how to recognize patterns in language and code them in a way that platforms such as Cogito, our platform, and further down the road, your platform can recognize those patterns in text and trigger on the concepts that you're looking to identify. So those are my closing thoughts. Thank you very much for your attention and interest, and we'd be really glad to open for questions.
Yeah, we've got time for a couple of questions.
The first one is the hardest. So who will be the courageous one? Yes, sir.
Technical question, if I
Sure.
can throw in. I'm curious about whether you normalize date and time information, and if so, what does that look like?
What does that?
What does that look like? What kind like, I worked with Timex way back when. Wondering if that's still relevant.
Right. So we do extract time information, date information, and we can normalize to the particular syntax that you want, if there is one. We don't invent information, so if it's not in the document, we're not going to be inventing it. We can infer part of it. If it says on January 19th we did blah blah blah, the year is missing. So if we can recover that information from another part of the document, we'll do it. And normalization, to whatever format you want.
Do you find references like last week?
We do find references such as that. That's a case of relative time, I would say, and those are things that we are able to recognize as well. Yes, not the easiest case, of course. Other questions?
Got one down here.
So you had demonstrated in the schema, like TTO,
Yes.
where you go and curate your information in the backend.
Yes.
So once you curate that and you update your layer, semantic layer, does it enrich in the future documents which come into the content database as such?
Yes, sir. So that's the purpose. The purpose is to maintain over time, the engine. The case I was showcasing was really an early stage of a project where you're building your initial, in this case, a thesaurus, but that can be done also over time within the life of the project. What we see is that in many cases, language evolves over time. So if you think of any domain, essentially, new terminology appears regularly. So there's an amount of maintenance that needs to take place, to make sure that the engines are still up to date. An example for, recent example in insurance, as you may know, we're going to have more and more driverless cars. So insurance policies for situations where a driverless car is involved, those are fairly recent cases that didn't appear on the map, before a couple of years ago. So writing policies to cover that type of case, this is a new type of situation that we find ourselves in. And even in a domain like insurance, there's new situations coming up regularly. So that calls for new terminology, to be built into the platforms.
So the follow-up question is, would you also integrate structured and unstructured together to
Right.
curate the data?
So I don't know if it goes towards your question, but there's an issue of entity resolution.
Yeah.
So if we talk about Paul Smith, are we talking about Paul Smith, the UK designer? Are we talking about the Canadian politician? Or are we talking about, Paul Smith, the biologist, who just happens to be writing an article, about cancer research? So those Paul Smiths, they all have the same name, but they're not the same person. And resolving to the right Paul Smith, that's really essential to connect structured information that I might have about the designer, the politician, or the scientist with the content or the information that mentions them. So resolution is a key topic in our field. We perform entity resolution. To do that, you need typically to leverage structured information about the entities at hand. So for example, Paul Smith, the designer, we know things about Paul Smith, that have been published on Paul Smith. We know that he comes from the UK. We know that he's going to be mentioned very often in the context of fashion. So those are clues that we use to resolve entities. It's not a perfect science. And right now, I think this technology works well. I would say if you have sufficient knowledge to act upon the entity resolution. But I would say that in many cases, we're going to have human operators there, if needed, to reach specific goals if we're not able to have enough knowledge about the entities that we're trying to resolve. Did that answer your question? I'm really sorry.
We've actually got to wrap this up now so we
Okay.
can clear the room for the next session.
Maybe
So
we
maybe
can
you guys can take
follow
it
up.
offline.
Sure.
Daniel,
Thank
thanks
you very
so
much.
much. Great
Thank you.
presentation. Lots to think about.
Thank you.